Hello and welcome to this session. Today I want to talk about how you can use Docker Scout to address security issues before they hit production. My name is Dupuis. I'm a senior principal and engineer at Docker working on Docker Scout. Before we go into a product demo and I'll show you how you can use Docker Scout to safeguard your images, I want to briefly talk about some theories behind Scout and supply chain security in general. Let's take a look at a very simplified view of a supply chain. There's a producer and a consumer relationship, and somewhere in the middle there's source code converted into a final artifact that is then shipped to a consumer. In the middle there's your build process, and while you're building your software, you're consuming other people's code, usually via base image dependencies in like when you're building container images, or like application level dependencies or S level packages that you may package into your Docker container. And this is all driven by like your Docker file. So converting source code into a final artifact during a build step, utilizing other people's code. Now, when you think about security in that whole process, a lot of people think about supply chain and areas where they are exploitable to really only be all the way to the right. Like when you have your final software artifact and you ship it or you deploy it to production, that's when you become commonly, like where people commonly think that they become exploitable. But actually look at all these various points in your supply chain, in your software delivery process. All the way starting from where do you consume your dependencies? Are these dependencies actually built by whom you think they were built? Or have they been tampered with? Have they been manipulated? And likewise, your build environment. You're using all sorts of software during compilation, during testing, third-party containers for databases, for example. How do you ensure that all of these things are actually authentic? What safeguards do you have in place to even know where things are coming from, or to verify that things are what they should be? Now, all of this is kind of like an area for software supply chain security. And to make securing these steps easier or possible, like we talk a lot about attestations. Now, attestations are pieces of metadata that usually refer to a software artifact. And these attestations have come in various flavors. So for example, we see a real surgence of SBOMs and kind of like SBOM tools in the industry over the last few years. There's even a mandate from the US government for producers shipping software to government agencies to provide SBOMs. SBOMs are software bill of materials. So what software, what packages have you included in your software when you ship it to a customer? So this is a very much like an ingredients table on your cereal box, right? You know exactly what's in the box, and that's what an SBOM is. Now, there's another type of attestation which is really all around how the software was built, by whom, what exact build steps were taken, and where, to tell the consumer of a software that this software is actually produced in a way that you as a consumer are expecting it to be produced. And then with all of those attestations, and there are many more types of attestations. So for example, we see VAX attestations to kind of document vulnerability exploitation. So are you vulnerable to a certain exploit? That you can express in an attestation called VAX. Or things like life cycle phases of a container image or a software artifact are all things that people start to put into an attestation. And then to make these attestations really verifiable and trustworthy, they should ultimately be signed so that the consumer can verify the identity of the person providing these attestations, to make sure that these attestations are actually coming from the person you think they are. Now, if we take this and apply it to Docker Scout and think a little bit about what are the areas where Docker Scout comes in here. So starting with the dependency layer down at the bottom here, think about Docker as one of the world's largest provider of trusted open source content. Docker official images used by millions and millions of developers each and every day has been around for a decade now, providing base images for all sorts of programming stacks, databases, and so on and so forth. There are other trusted content programs with Docker that you can find on Docker Hub, Docker verified publishers, Docker sponsored open source. So there should really be a base image for everyone out there. And then if you think about attestations and how important they are in the whole software supply chain security world, attestations are a means to transport data. They are attestations, kind of like facts about a piece of software, but you really need to enable workflow on top of these attestations to make them useful. So Scout's really all about storing attestations, facts about software as it moves through your supply chain, and then providing a way of do policy on top of these attestations. And with policy, we really mean across all phases of your life cycle, software life cycle, not just for things that are running in production or when you want to deploy something in production, but also very early in the supply chain on a developer's machine, right? Pulling a container image, you should really evaluate policy on that container image. Is this trustworthy? Building a container image, is the base image trustworthy? Are all the ingredients that go into your container image, are they trustworthy? Are they the components that you expect them to be? And that's all about policy evaluation at every point of the supply chain. And that's what Docker Scout is. Enabling policy on a local developer machine during build, during CI, and then ultimately when you ship the software to your consumer, or while it's at rest in your container registry, or while you're running it in a Kubernetes cluster, for example. At all of those stages, we want Docker Scout to provide these kind of policy insights. Now, here's a brief kind of couple of screenshots about Docker Scout. I want to go way deeper into the product in just a little bit. Just to highlight, Docker Scout comes with a web dashboard. It has very deep, tight integration into the Docker CLI, the CLI that every developer is using. Everyone who is doing containers and Docker builds and stuff like that, you will have the Docker CLI installed. And for a lot of those people, Docker Scout is already available as part of our Docker desktop distribution. Both, and you see this in my demo, the dashboard and the local CLI experience are very similar into what they provide in terms of insights and how they can use and guide a developer to kind of remediate security issues in their container images. With that, I want to jump over and actually do a product demo. Right, to do this, I went over to the Scout dashboard here. I logged in with my Docker Hub user. Everyone that has a Docker Hub user can log in, sign up for Scout. There's a free tier that you can use to sign up and explore Scout and its features. The first thing that you'll notice after signing up, logging into Scout, is this overview page listing and giving you kind of insights into the security posture of your container images. And it starts off by a couple of out-of-the-box policies here that you can see on the screen. We have policies around package compliance. So what licenses are you using? What licenses is your organization allowing you to use? Is it okay for you to use GPL v3 licenses and so forth? Things like container best practices. Are you running a container as non-root user? Again, best practice. We're going to be checking that. Things around fixable, critical, and high vulnerabilities, usually the ones that have heavy, kind of high exploitation rates, are the ones that we bundle in this policy and kind of highlight for our customers. And then high-profile vulnerabilities like Log4Shell, XZ, all the things that are very zero-day, where you need immediate feedback of things that you should take care of and get immediate kind of activity going on. Two very interesting policies if you think about the world of container images, making sure that your base images are always up to date. So Docker official images and internal base images are continuously moving. But how do you make sure that your consumers of these base images continuously move and update their own images when you update the base image? That's the purpose of the outdated base images policy. And very likewise, unapproved base images. Very often customers are asking us, hey, I want to make sure that my developers only use base images from trusted sources. Well, that's the policy for you. Then you can go in and configure which images you allow people to use as base images from which registry, not just Docker Hub again, but across kind of like any registry for that matter. And then lastly, fostering and tying this back into what I said at the beginning, making sure that each image ships the required supply chain attestations, SBOM, provenance, VEX over time, and so on and so forth, ideally in a signed state, so that it is becoming cryptographically verifiable. Those are the out-of-the-box policies, and I want to jump in and show you how you can use these policies to kind of improve the security posture of your container images. Before I do this, I want to briefly touch on the concept of environments here. Again, the fact store, it helps you record additional data about your container images. In this case, I have an environment called prod, which is short for my production environment. That is my own personal production environment, just for demo purposes, of course. It currently only has one image, and that is not quite within compliance. So if I want to drill in and learn how I can address these security issues, I can jump into the images tab, and then from there into the image tag. So this is now the image that is running in my production environment. I have a little cube cluster on the side where this image is running. And I can now see that there are quite a few things wrong with this image. So apparently I'm using copyleft licenses. In my image, there's one package that is apparently violating this. I'm running this as a root user apparently. There are fixable critical high vulnerabilities and so on and so forth. So I really want to go off and start fixing these things. Before I do this, I want to show you another tab here, the images layers tab, which is a really useful way for you to understand the composition of your images. It has an image hierarchy that kind of shows you the base image hierarchy. So I'm using Alpine 314. And then you can go about clicking individual layers, and that shows you like which packages are getting introduced by these layers. So this package introduces 52 packages, and with these 52 packages, I'm getting 3 vulnerabilities introduced into my software. But what I want to do is I want to kind of now take this code, take this application, and move over into the CLI and start remediating some of these things onto my developer laptop. And to do that, I'll jump over into the CLI here. And the first thing I'll do is I can say Docker Scout quick view, and then say the image that I kind of looked at in my web front end to kind of get a quick sense of how is this image looking like? What are the various aspects that I need to go off and fix? So let's have this command execute quickly for us. So what now happens is it brings down all the information into my inner loop. And you can see this looks very similar to the web front end here. And we can see that I'm using my Alpine 314 base image that has a couple of vulnerabilities. I get a new base image suggested, and I have a few policy variations here. So let's start to drill in a little bit more and start look into the actual policy variations that we can go off as a developer and address locally here. So now I want to kind of get the full list of all the details and ideally kind of help me remediate some of these things. So you can see that there is a copyleft package, GDBM. I'm not using a non-root user. There are a couple of packages that I should really go off about and fix. My base image apparently is out of date, so there is a newer version of the Alpine 314 tag. But then lastly, there is this here, Docker official image tag 314 is unsupported. Well, Docker Scout is telling me this image, despite being out of date, is also not supported anymore by the Docker official images program. Well, that's a great insight for me, which can immediately lead me to running the next command, which is the recommendations command, which I can now use to get a really kind of concise recommendation on what base image to update to. So scrolling back up, again, the same image. My base image currently is one from 2 years ago, so it's really out of date. And Scout is now telling me the 320 tag is the most preferred tag that I should use. It has a couple of justifications here that allows me to really reason about which one of those to pick. I do see that if I updated my build to use this image, I would immediately fix a couple of vulnerabilities. So why don't we start this and head over into VS Code and just really quickly make a very, very small update here. So you can see Docker Scout integrated in our kind of VS Code environment here. You get kind of like the same recommendations. I should really go to like 320, so I can do this now. Hang on, I should probably use the quick fix. So I'm doing this, and it's also doing one of the other best practices here. It pins our base image. So let's save this, head back over into the CLI and say docker build. And in this case, I'm actually running a local build here because remember, I want to quickly verify things before they hit production, before they go into CI, and kind of like hit the expensive loop that takes usually a couple of minutes, if not hours, for us to get feedback. So now I have this image kind of like built locally with a new version of our base image. And I should be able to run policy now against the local version of our image. So I can say now local, and then remember, I named my image local here. And by using the local prefix, I tell Scout to really use the image that was locally built instead of like going off to the registry and pulling the image. And what's happening now is it actually went off and evaluated the policy locally instead of pulling the results out of the Docker Scout backend. And now you see that our outdated base image is kind of like, okay, we have an approved version of our base image here, and we are only left with like 3 things to worry about. And this is actually fairly straightforward to fix now. I see that there is a GDBM dependency that is GPLv3. I'm not using our root user, and there are still 2 package vulnerabilities that we want to fix. And the way we can do this, we kind of see exactly that Express is the vulnerable package here that we want to update. And to get even more detailed information on where this is coming from, you can run the docker scout CVE command, again, on the local image. And that will use all the attestation data to give you exactly a piece of insight on where this is coming from. So going back to our Express dependency here, we see that this is coming out of the Dockerfile 14, line 14, and this is the exact statement that we are running here in our Dockerfile. And then I can look into the various CVEs here. There is one that is fixed in 4.17.3, and then there's one that is fixed in 4.19.2. So I'm better off updating to 4.19.2. Heading over into VS Code, I can directly jump into the package.json now, which is the file that I'm using, and can save this, go back to iterm, and run our build again. So if I did this correctly now, again, I would expect these vulnerabilities that were introduced via the Express package to be kind of like eliminated from our image. Running the scout CVE command again will show us that there are only busybox and OpenSSL packages left in this particular, vulnerabilities left in this particular image. But remember, there were still 2 other policy variations here that we want to go and fix. So let's just remind ourselves what those were by quickly executing this command again. It's this copyleft license and default root user. So heading back over into VS Code and trying to search for where these things are being added. And I can see in this particular line, we're adding GDPM, and someone, perhaps by accident, removed our explicit user from our Docker file. And again, heading back over into the Scout or the Docker build CLI here, running the build, again locally, for hopefully one last time verify the outcome of our build. There we have it. This looks very, very green. This is exactly what I wanted to show you. Using Docker Scout locally, without pushing anything into an expensive CI pipeline, you get immediate feedback on how to address security vulnerabilities. But now let's take it a step further and actually attempt to compare this to what is currently running in production. Remember, I showed you the prod view in our dashboard. You can bring this context locally with Docker Scout. So I can take my local image and compare it to the version that is currently running in production, just to verify that the things that I changed are actually improving our security posture. Here we go. Here we now have the results of our comparison, the image that we built locally compared against the one currently running in production. So if we scroll up all the way, we can see, as you all know by now, we updated our base image to 320. With that, we eliminated quite a few vulnerabilities here. With the build, now a different git commit, different git char. We changed a few environment labels here. And very notably, we fixed 20 critical and high vulnerabilities. We fixed one of the copyleft license issues, and we actually moved our base image to the latest version and to an approved version of our base image. And if you're really interested in like the various very nitty-gritty details, remember SBOM at the beginning of the presentation. You can take a look at each individual package and how it was changed. For example, we upgraded BusyBox from 1.3.3 to 1.3.6. With that, we fixed quite a few vulnerabilities. So at this point, I'm actually fairly confident that if we push this up into Git, we end up with a much better image. So let's create a new branch. And push this up. CV fixes. And we can now head over to GitHub to raise the pull request. Make sure that we raise it against the correct repo here, since this was a forked repo. And now we have to wait for our CI build to kick in. This is happening now. The build is now almost finished, and we see another check here, the Docker Scout policies check. And this is a way for Docker Scout reporting progress immediately back to the developer, where it happens in GitHub. So while reviewing the PR, they can get a good glimpse at the security posture of this image. So the data is still coming in, and you can see quickly here, this is the image, the left column here is the image that we've built on the PR branch, and it has all green checks here for all the policies. Comparing this against the image on the PR target branch, in this case I want to merge into main, and also against the image currently running in production. So it's another view similar to what I showed you earlier on the CLI, comparing images, local images to production, in this case the image built from the PR branch against the images on the target branch of the PR versus the one in the environment. This is a nice conclusion for this talk today, showing you how you can utilize Scout to really effectively fix and address security issues very early on before they hit your production environment. And with that, I want to thank you all for your time today. Make sure to leave questions. Happy to answer all of those questions individually, and hope you enjoyed this presentation. And go check out Docker Scout. Thank you very much.